Hello. Hello and welcome to this video. So the first change you would notice is that I have to manually click on start recording instead of pressing a hotkey because in Wayland you cannot capture keyboard just like that. It has become far more strict about capturing keyboards from different windows. The window must be in focus to capture the keyboard. So I have to manually start and stop OBS Studio's recording. So, okay, recording has started. Now, in this video, we will talk about databases. I don't know at what stage you are in your career, whether you are a student or a professional, but I'll assume that you have no experience, or you might have some experience. It does not matter really. The content of the video will be equally beneficial for all the users. So what we are going to discuss is what database should you choose for new applications. So in general, we are talking about large scale web applications or world scale web applications. If your application is small, then you can probably just use MySQL or MariaDB or PostgreSQL and you will be fine. But suppose you want to make something like Facebook or LinkedIn or something on the world scale, Twitter or things like that. Now, there are certain databases which are not included here. For example, ScyllaDB, which is a Cassandra clone, is not listed here. There is CockroachDB, which is a Google standard clone, distributed SQL database, not listed here. So there are tons of databases not listed here. For example, Dragonfly or Aerospike, which are alternatives of Redis, are not listed here. So I will not go through all these databases. I'll just point out general recommendations on what databases should you use and what you should not use. So if you don't know anything at all about databases, the safest bet of all these databases for you is PostgreSQL. The reason is it is open source, free, it is quite mature, and there are tools with which you can scale. There is Citus Data Extension or pgdog, which help you to scale PostgreSQL horizontally. But suppose that you have some experience with databases, then what should you do? So consider that we are developing an analytics application, or for example, we are creating an advertisement rendering application. Then what should we choose? So you can see that there is no immediate consistency or asset requirement in these applications. So what you should choose is ScyllaDB, which is a Cassandra clone. Now ScyllaDB is crazy fast. The reason is that it is based on a framework called C Star, which is state-of-the-art work of engineering. I have talked about C Star in my many other videos as well. So what you should do is you should use ScyllaDB if consistency is not a requirement. In general, what I would like you to do is stay away from Oracle, SQL Server, MongoDB, DB2, and Amazon DynamoDB. I'll tell you the reasons why so. So Oracle and SQL Server are commercial, so you should stay from these, clear from these, because you will burn a lot of money while not needing the features all the time. And CockroachDB is a better alternative in terms of database compared to Oracle and SQL Server. MongoDB or, for example, Couchbase or SurrealDB, which are document-based databases, you should try to avoid using those. Why you should avoid using document-based database? The reason lies in a very simple observation. So these are document-based databases. That is, in a document, we have a lot of data compared to a column and a cell of SQL. So the document has lots of data. Now suppose that you want to update only a small part of the document. So workflow goes like that, is that you fetch the entire document, usually represented in JSON in your code. The database may store in binary format, that is not our concern. In your code, it would be typically a JSON object. Now we want to update one of the keys. So you fetch the document, you update the key, and then you put the document back. But note that when you fetch the document and then you do something and then you update the key, or you retrieve a particular key, do some computation, and then you update the document, send it back. There's a time window between the fetching the document and updating the document. There's a time window. Okay. What the time window, in the time window, what can happen is another application can pull the document and update the document and put it in the database. So now what will happen? The first logic which pulled the document will overwrite the document. So there are two ways you can circumvent this. The first is compare and swap. That before you save the document, you compare the existing document with the original one, that it is the same, and then you swap the document. This is known as optimistic locking. So, but note that all this will cause loss of efficiency. Now, the second way to solve this problem is that you take a lock when you pull the document, and then you update and do whatever logic you want to do, and then you put back the document and release the lock. This is called pessimistic locking. Now, when you do this kind of nonsense with the document-based databases, the performance degrades by a lot. And that is why I will never ever recommend anybody to use a document-based database. It is just problematic. Apart from trivial or very simple applications, I will never recommend a document-based database. MongoDB, Couchbase, Serial Database, Cosmos DB, stay clear from those. They bring a lot of problem and it is just not worth it. Instead, if you want to use MySQL, go with MySQL. There is Lotus to scale it. You want to go with Oracle, SQL Server, MariaDB, fine. DB2, all the databases are fine, but not document-based database. Elasticsearch is a search engine, so if you want a search engine, you can use Elasticsearch, or you can use Sphinx, or you can use something like Solar, or there is an Elasticsearch clone prepared in Rust, is called Quick-Wits. So I'll show you Quick-Wits. Quick-Wit. So this is Elasticsearch compatible database. The API is compatible with Elasticsearch. Very fast and consumes a lot less resource. Can vertically scale. Elasticsearch cannot scale vertically because of the GC-pos issue. Although you can run Elasticsearch with the new JetGC garbage collector and scale vertically quite a lot. But then at the time of GC-pos, the memory consumption spike is very high. Now we talk about Redis. You have quite a few options here. You can choose Redis, Aerospike, or Dragonfly. From my experience, Dragonfly is best. It has higher performance, and the API is Redis compatible, so you can use Dragonfly. That is a commercial solution, but there is a community edition. Now we come to key value databases like Amazon database. The problem with the key value databases is very simple. The problem is that you have to write a lot of user-defined functions. Unless you write user-defined functions to query the database, they're not very useful. For complex scenarios where your queries can be complex, don't use key value databases. So in general, my recommendation would be use PostgreSQL, Dragonfly, ScyllaDB, CockroachDB. These are the 4 or 5 databases I'll recommend in general for large-scale systems. If you're doing something like financial applications or banking applications or wherever money is involved, stick to PostgreSQL or CockroachDB. If you don't have that kind of strong consistency requirement or the querying is not very complex, use ScyllaDB and Dragonfly everywhere for caching memory. If you have got something like an online game which needs a database support and you need a bit fast response as well as commercial support, Oracle can be a nice choice. If you want to stay close to Windows environment, SQL Server will work as well instead of PostgreSQL. But wherever you can put Oracle or SQL Server, you can use Cockroach DB. This is the website of Cockroach DB. It is my favorite database of all databases. It's the best from what I have seen. It is somewhat on slower side, but it's not that slow. Yes, it will be in general a bottleneck, the speed of database, but it is also reliable. And as you can see that it is usable for mission critical stuff. Very reliable piece of software, CockroachDB. It is Google standard clone, can scale very highly. So I think I have given quite a bit of overview of what databases one should use. I will show Dragonfly as well. Dragonfly. So this is Dragonfly. You can download the community edition. It will be somewhere here. You can go to GitHub. You can download from there. You go to GitHub, look at releases, and you can download from here, Dragonfly database. Okay. So I think this video in general lays a solid ground for what you can do with the different types of databases. And I'll stop here. So if you have liked this video and found this video useful, make sure to subscribe the channel and like the video so that it motivates me to make more such videos, as well as the YouTube algorithm is used to increase the reach of video. So let me know in comments what do you think about the video and what are the topics you'd like videos on. Thanks a lot for watching. Enjoy.